Hi, in this tutorial we're going to connect to the Nebula 2.0 to IBM Watson IoT Quick Start and build a scriptr.io application that will read the data from Watson, process it, and visualize it on a dashboard. For this proof of concept, we chose to use the WeatherClick environmental sensor board from Microelectronica to read the temperature, humidity, and pressure, so make sure to attach it to your Nebula device. Before you start, download and install the Wicked Studio IDE, which you will need to program the Nebula device. Its link is under the Software Prerequisites section in the tutorial. Next, you need to register to Scriptr.io if you don't have an account already. You can either follow the registration link you find in the tutorial under the Software Prerequisites section, or go to scriptr.io/register and enter this promo code. Fill out the registration form and submit. Then click the link in the verification email, which you should receive shortly afterwards, to confirm your email address. Then log in. On your first login, you need to wait a few seconds as Scriptr.io installs the device's application on your account. If you already have a Scriptr.io account, then you need to check out the Device Agnostic app from GitHub and run its installer file. Make sure to read the installation instructions in the README file to learn how to do it. Now that your Scriptr.io account is ready, let's program the Nebula board. First, open the Nebula 20 Watson GitHub repository to download the project. Click Clone or Download, then download zip. Extract the downloaded package and open it. Copy all 3 folders to your clipboard. Then navigate to your documents. Open the Wicked Studio folder, then open the 43xxx_Wi-Fi folder and paste the package content. Windows will ask you if you want to replace the existing files or skip. Choose Replace. Now open Wicked Studio. Make sure to select the filter 43xxx_Wi-Fi. Then navigate to the Wi-Fi config dct.h file and open it. Here you need to configure your Wi-Fi network settings by setting the client app SSID and passphrase variables to the values corresponding to your local Wi-Fi settings. Save your changes by hitting Ctrl+S on the keyboard and open the watson.h file. In this file, you need to configure the MQTT settings to connect to Watson IoT Quick Start by setting the publication topic and client ID. To do this, you need to replace the token fields with the token provided to you in your Scriptr.io account. Switch to your Scriptr.io workspace. You will find the token in your landing page. Select it and copy it. Then switch back to Wicked Studio and paste it, replacing the 2 token strings. Then save your changes. Now we're ready to create a build. Right-click the projects folder and select Make Targets and choose Create. It's important that you set the target's name correctly, otherwise the build will fail. To get the target name, your easiest option is to copy this value from the tutorial. Paste it here and click OK. You should see this new Make Target here. Before we build and install it on the device, connect the Nebula to your PC using a USB cable. Make sure to connect it to the USB debug port, then open a terminal tool so you can view the device output. We're going to use TerraTerm. Create a new connection by selecting the Wicked USB serial port option. Then go to Setup and select Serial Port to configure the port settings. Set the baud rate to 115/200 and click OK. Now go back to Wicked Studio and double-click the Make Target to create a build. As it builds, open the IBM Watson IoT Platform Quick Start page and enter the device ID. You can find the device ID in your workspace. Copy it and paste it here. Then click OK. As soon as the app is built and installed on the Nebula, you will start seeing the output in the terminal. Once you see the message starting event loop, Watson IoT will indicate that a connection has been successfully established with the device by displaying this message. When you click button 1 on the Nebula board, a message will be sent to Watson IoT, and you will see it on this line chart. We're all set now. It's time to run the application. Go back to scriptr.io and open the Smart Kitchen folder. Double-click the index.html file to open it in the editor. Then click View to open it in your browser. Log in. The username and password are demo. You will see the device in a random location on the map, unless you use a sensor board that sends GPS coordinates. Zoom in on the device and click its marker for a quick view of the sensor's reading. All the readings in this application are displayed in real time, so the values will be refreshed as soon as you press button 1 again. The View Dashboard button will open a dashboard showing the current and historical readings. Whenever an anomaly is detected, a warning will be logged to the database and displayed in the Alerts page. To tell the system how to detect an anomaly, open the Rules Designer and define the limits for each sensor's value and the designated course of action. This column shows rule number 1, which states that if the temperature goes above 8 degrees, an email is sent with a high temperature warning and an alert is logged. Rule number 2 states that if the humidity goes above 30%, a high humidity warning is delivered by email and an alert is logged to the database, and so on. To specify the email address that will receive these warnings, go to Notification Settings, write the email address, and click Save. This is how an email warning will look like. If you wish to modify the application, I recommend you read the README file under the App folder in your workspace. If you have any questions, feel free to send a support request from here or send us an email at support@scriptr.io. Thank you for watching.